Since you guys have been having fun, I want to keep having fun. At least my version of fun.
Okay, go ahead, Bob.
Yeah, you know you want to hang out with me on the weekends. Hey, let's go have some fun. Let's go. Walk into the clubs, MathMan 1024 in the house.
That's what I was saying.
So when I have 10 plus the square root of 7 times 10 minus the square root of 7, what are you going to do here?
Like all my exes.
Do they live in Texas?
Now, I know what I would do here, but I want to see if you guys know what I would do. I would recognize.
It's the same thing, but it's just one.
I want you guys to recall.
That's two different squares.
Thank you. This is the difference of squares, isn't it?
Yes, it is. 1 plus and 1 minus.
So that means I should have one thing squared minus the other thing squared, right? So that means I'm going to have 10 squared minus the square root of 7 squared. What's 10 squared? Not 20. Good job. What's the square root of 7 squared?
9.
That is horrible. The square root of 7?
Squared is what?
The square root of 7? 7. I knew it was something with 7.
Why?
Why?
Oh, I'm thinking about it.
Wouldn't the square root and the square cancel each other out because they're inverse operations?
Didn't we do that yesterday?
Now, if you didn't like that, if you were to square this guy, you would get the square root of 49, which equals what? 7.
I feel that way.
But this is a lot easier because I don't have to worry about what 7 squared is. See, did 10 have a house? No, so when the square comes, when that radiation hits, he gets mutated. He's like, this guy's in the bomb shelter, so when the radiation hits, he's like, oh, I'm still 7. Oh, my God, that's 100 now! So then you just finish this, and you just get 93. Isn't that was awesome? I'm like wigging out here. See, never mind. Now I'm going to show you
It's 49.
the square root of 85
Why
minus
would
the
I do that?
square root of
We'll
41.
talk about the first one.
I'm going to do this next one. You're going to see why you don't want to do what you were just saying. Am I multiplying conjugates here where I would get to use the difference of squares? Aren't these conjugates?
Yep.
Same two guys here, but 1 plus and 1 minus. So,
that's 8 minus B.
according to the difference of squares, I would have the first guy squared minus the second guy squared. So that's the square root of 85 squared minus the square root of 41 squared. If you're going to sit there and say, all right, well, 85 squared is 7,225, and then the square root of that is, you're not going to do that. Because, number one, you probably don't know, or you didn't know that 85 squared was 7225. Even if you did, and you were able to figure that out, then you're going to be stuck without a calculator trying to figure out what's the square root of 7,225. When we should recognize that when you square a square root, those guys are going to cancel each other out because they're inverse operations. And I have just what? 85 minus, same thing over here. That's 41, so what's my answer?
44.
The answer is just 44. I don't need to worry about large numbers, and when you do, that means you're not understanding and paying attention to what's going on, and you're creating difficulties for yourself. Like back up here, I could have done 7 squared and then had that inside the square root, or I could recognize that when I square the square root, those guys are going to cancel each other out, and I get just 7. It simplifies my work, it makes my life easier.
But if you're multiplying,
What's the question?
if you're multiplying the power times the index.
I'm not multiplying the power times the index. if you were to see anything at all related to the index, because you have to understand that when you're working with exponents, and you want to do, you don't do power times index. I've never ever said
Or
that.
divided.
You could say that the square root of 7 is 7 to the 1/2. You could say that. And then when I square this guy, I've got a power to a power. What do you do when you have a power raised to a power? What do you do when you have a power to a power?
They cancel out.
No, you multiply them.
Multiply.
So that means that's 1/2 times 2, which is 2 over 2, so that's just 7 to the first, which is just 7.
Oh, okay, so you go.
Or you could just say, okay, the square root and the square cancel, and be done. Let's try uno más ejemplo. So if I have 5 square roots of 8 plus 7 square roots of 3 times 5 square roots of 8 minus 7 square roots of 3.
Oh, you can only do this with squares. The difference of cubes is only.
Well, difference of cubes is that we don't,
Can't do that.
what we're working with is working with conjugates. And so the result of multiplying conjugates will be the difference of squares. So it's going to be one guy squared minus the other piece squared.
Uh-huh.
So that's 5 square roots of 8, 7 square roots of 3, and I've got to square. So I've got to be careful when I square this. We need to understand and recognize that this is a product in here. 5 times square root of 8, 7 times the square root of 3. So when I square, I'm squaring each factor. Okay? Square each factor. So when I square the 5, what do you get? Times, now I square the square root of 8, what do you get? I just get 8, right? Because the square is going to cancel with that square root. Minus, over here, when I square the 7, what do you get? But when I square the square root, what do I get? I get just 3. So here's what you need to recognize. This first step is using the difference of squares from 0308, section 5.4. This is a combination of this particular chapter and working with exponents. When you have a product to a power, each factor gets raised to that power. So you're looking at doing this. 5 squared is 25. The square root of 8 squared is 8. The rest of this is 0306 material. It's pre-algebra. So what's 25 times 8? 200 minus what?
147.
Minus 147, what does that equal?
53.
That equals 53. Now, you could check this out and verify this on your calculator. Right? So if I type in what I have, you all right there?
Ooh, you know what I'm talking.
So if I have 5 square roots of 8, now see the way this is set up, I'm still inside the square root, so I want to get out of that. Plus 7 square roots of 3. And I'm going to do the same thing, almost. 5 square roots of 8 minus 7 square roots of 3. What did I say the answer was?
53.
I better get 53. Now, it does a little bit of a rounding error here, so I'm not completely happy with that. But it really is 53. There's just some rounding errors that's got going on there. Let me change my mode real quick. And if I go back to the classic mode, which is what you would see on a TI 83, for example,
Yeah.
you would see this 5, and when I do the square root of 8, see how it opens up parentheses for that?
Yep.
So 8, then you close the parentheses, instead of having to arrow out from being underneath the radical, plus 7 square roots of 3, close the parentheses on the square root, close parentheses on the first factor, the first binomial. And then 5 square roots of 8 minus 7 square roots of 3. So there we go.
Oh, that's cool.
So this is more the style that you would expect to see if you're using a TI-83 or an older version of the operating system on the TI-84. Okay, we can even check the last one real quick, just for grins. I've got the square root of 85 minus the square root of 41. Close parentheses for the square root. Close parentheses for the first factor here. And then the square root of 85, close parentheses, plus the square root of 41, close parentheses on the square root, close parentheses on the second factor. It gives me 44. I know that's a lot of stuff to type in when you do that, but it's a lot better than using your basic 4-function calculator and doing this. Getting the square root of 85 as a decimal, getting the square root of 41 as a decimal, and then having to do operations with that.
I
Question?
got 53, just 53 on that.
On the first one?
Yeah, we got the.
Well, there must be some kind of rounding error going on with mine.
Oh.
When you're dealing with a lot of decimals like this, it's very easy to run into rounding error depending on what your operating system is, how many decimal places does it keep track of, when does it round.
So when you're checking this on the calculator, you need to always put a closed parenthesis after the closed parentheses of the number inside it to.
Well, you understand when you do the square root, it starts by opening up a set of parentheses. So when you're done with that, like whatever number you type in, you need to make sure that you close that off. You have to be very mindful of your parentheses, just like if you were working in, say, Microsoft Excel with a formula. You have to make sure that you have the same number of opening parentheses as closing parentheses so that things match up correctly. And it's important with the graphing calculator, with Excel, if you're doing things in computer programming, you've got to make sure that you close things off the way you're supposed to.